Today we're going to start talking about descriptive statistics. And what's that? Okay. Descriptive statistics are things we can calculate from a list of numbers that tell us something about the data, like the average is a statistic, a descriptive statistic, the median, the max, the min, the percentiles, for example, the 10th percentile. These are all descriptives that help us describe the data. Okay, so go ahead and open Notebook 9, and we're going to talk about how to calculate the mean and the standard deviation. And there are several interesting things in this notebook, and we're going to spend a good amount of time in it going over the information. But the first thing is we have already learned that we can calculate the average of an array of numbers, right? NP average and NP mean. And And then it turns out that we need to consider the difference between the sample and the population. So we have two different ways. So for the population, the mean is, this is the Greek letter mu and the Greek letter sigma. So mu and sigma represent the population mean and the population standard deviation. And for the sample, X bar is the mean and S is the sample standard deviation. What's the difference? Well, the sample are the individuals that are actually in the research, right? They're the folks that we've collected the data from, or the lab rats, or the whatever it is that's part of the study. That's where the sample numbers come from. The population, this is everybody that the research applies to, right? So if you're studying perfectionism and you use a college sample, say at the University of North Georgia, then your population might be college students in the US or maybe college students in the Southeast, so the data may apply, the sample data as research that we do research on may apply to a wider population. But the sample is what we're focused on, okay? And that'll become important in just a minute because it turns out there are slightly different computations that we use. Okay, so let's jump into the notebook, and yay, this is great. Let me pause the video and get D2L. Okay, I got D2L awake, and so here is Notebook 9, Descriptive Statistics. So let's go ahead and run the initialization code. And we have a nice little animation here to explain what the average is for a group of numbers. And if we think of each number as a little block and all the blocks weigh the same thing, then the mean, right, is the balancing point. If all the blocks weighed the same thing, the mean is the place where you could balance those blocks, okay? And again, does it matter? No. NP mean or NP average will both work as long as we're talking about a single array of data. And again, the mean is the balancing point. Okay, so here we go. Here's values 2339, right? If we add them up and divide by the number of numbers, that's the average. Also, the sum of the values minus the length of the values is the same thing. So that's a way to calculate the average. And if I do NP average, I get 4¼ And if I do NP mean, I get 4¼ Okay, so here's a new array of numbers, new vals. Okay, and what are we doing here? Well, we're just creating a little histogram. And notice that the numbers are just 2s and 3s and 9s. Okay. And NP mean for all of these values, again, it's going to be 4¼ So the mean is a fairly easy one to calculate. Now we're going to talk about the sample standard deviation, okay? And let me, wow, this is, these equations are not showing up and I don't know exactly why, and I'm running this cell and it won't rerun. But let's just go with this. It's a measure of the spread, how the values in the array spread out around the mean, okay? And so the standard deviation of the table where we're creating a column, well, okay, let's look at this table. Let me just show you. So we're creating, right? SD table is a table with those 4 values, okay? Notice that we grab column 0, which is the only column in the table, right? And do NP average. So we're finding the average value, which is 4 1/4, just like it was before. Now deviations, values minus the average. So in other words, I take every single one of these numbers and I do minus 4.2. That's the deviation. So the deviation for the first data point is minus 2 1/4, the 2 minus 4.25. And I do that for the 3 and for the 3 and for the 9. And those are the deviations. So now we're creating a new table with the column deviations. All right, let's see what that looks like. Let me run this cell. Okay, and just like we said, you can see that 4 1/4 is being subtracted from the value to get the deviation. Why did we do that? Well, we're showing you how to calculate the standard deviation. Okay, and we're going to square all of the deviations, right? So with columns, squared deviation, what are we going to do? We're going to take 2 1/4 and square it. That'll be positive. Notice that we're going to have all positive numbers in this column, right? Because we take the deviation and square it. Okay, and then what the standard deviation is, it's basically the average squared deviation, right? We sum up all the squared deviations and divide by the number of numbers. Okay, and notice that we don't just divide by the number of numbers, instead of dividing by 4, we do 4 minus 1, which is 3. And so they're going to say that's the variance, and I take the square root of that, and that's the standard deviation. Okay, so what do? The deviations are just the distance that the data point is away from the mean. Positive deviations mean the number is above the mean, and negative deviations mean it's below the mean. But then I square those deviations. So then I get a column of all positive numbers, the squared deviations, and then I basically average those and take the square root. That's what gets me to the standard deviation. Now, what we're going to do is this. The sample standard deviation is in the stats package. So stats.tstd values, and notice that the exact same number that we calculated up here with 4 or 5 steps, we can do real quickly right here. Now, it turns out there is another value, right? So notice the difference here. It's STD versus TSTD. And the TSTD, this is the one we're going to use for standard deviation. Why? Because it's the sample standard deviation. And this gives us the population standard deviation. So it's not bad. It's just that we're working with sample data, and so we're going to use the sample standard deviation. So stats.tstd is how we're going to find the standard deviation. All right, now this goes through some discussion of it, and again, I'm not quite sure why my equations are not showing up in display mode. Okay, yeah, my kernel looks like it's gone to sleep. So I am going to pause the video and get everything woken up so we can see the demo, because the demo is actually enlightening. And I'll be back in just a second. Okay, I'm back and my kernel in my computer has woken back up. And so what are we talking about? Well, it turns out that the sample standard deviation is unbiased, which we think of as good, and the population standard deviation is biased. What do we mean? We mean that if the true value is listed here as the green triangle, then the biased calculation is this red square. Same thing here where we have a unbiased estimation, right? This is the sample standard deviation. It gives the value that's closer. So it's just a nice picture of why we have these two standard deviations and why we prefer the sample standard deviation. It's just going to be more accurate. Okay. And there's another demo that's almost identical, and we'll give it a second. I thought the kernel was awake. Okay. Let's jump back up here. So Again, we're going to use the sample standard deviation, TSTD. All right, and we're not going to cover Chebyshev's bound, which is the next section in the notebook, because it's not on the midterm. What we're going to go to is the box plot, which is a picture of the 5-number summary. And the 5 numbers in the 5-number summary are the max and the min, the median's in the middle, and then Q3, which is the 75th percentile. I'm sorry, this should be Q1. Right, Q2 would be 2 quarters, right, which would be the wrong thing. So I'm sorry, this number here should be Q1. Q1 is the 25th percentile. Okay, and why is that important? Well, we'll talk about it. Let's see some examples, and then life will make a lot more sense. And I'm just going to quickly step through these. Why? Well, just in case there were any data up there. All right. So the median. So we can do NP percentile, and here we sort it and figure out where the percentile would be. The 50th percentile would be 34, and if we do the median, we get 34. So it turns out that this NP median works, and we can also use the 50th percentile. However, about half the time, the NP percentile gets the wrong value. Okay, why? Well, there's this problem that sometimes we have to average the two in the middle. Now, it sometimes is fine, right? But our recommendation is to use np.median rather than the 50th percentile. Okay, and this one is an example of where we get 34 if we do the percentile. We do the median. And so different ways to go. Sorry. If we're looking at the 50th percentile of X2, we get 34. If we're looking at the median of X2, we get 38.5. So again, there are sometimes differences because percentiles are calculated differently. The median is essentially the 50th percentile, but in fact, we'll just use NP median here. And again, in the notebook, they show these values, and notice that I had Q1 listed as Q2 instead, so this one is correct. All right. Now here they make an array of these percentiles, the 0th percentile for the minimum and the 100th percentile for the maximum, and 25th, 50th, and 70th percentiles. And they calculate the 5-number summary, right? So this is the 5-number summary. These 5 numbers is a way to summarize the data set. And why? Well, check out this. If we do a box plot of the data set X2, it's actually a picture of the values in the 5-number summary. Okay, so this is the maximum. We draw a fence up here at the maximum and a fence down here at the minimum. The red line is the median. This is Q1 or the 25th percentile. This is Q3, which is the 75th percentile. So that rectangle is showing the middle 50% of the data, right? So we know that half of the data are here between about 25 and 55-ish. I mean, I'm just guessing. Obviously, it's 56.2, and anyway, so so the rectangle shows the middle 50% of the data. Okay, and that's interesting. That's helpful. Let's take a look at this. This is going to do the same thing that I did. It's going to emphasize the fact that the box plot is in fact a picture of the 5-number summary. And it's the same way all the time. But the cool thing is that the fences are drawn to check for outliers. Now this data set doesn't appear to have any outliers. Let's go on and see what one looks like when it does have outliers. Okay, so in here they're showing you the interquartile range, the IQR. The interquartile range is the height of this rectangle. It's Q3 minus Q1. And why do we use it? Well, we use this IQR, this interquartile range, to calculate outliers. So here we actually just had the computer calculate the IQR, and it's 30.25. Okay, and what's going on? Well, in the distribution of x2, all right, we are calculating this, and everything is shown there. You can see the IQR is the height of the rectangle, right? It's Q3 minus Q1. And I will let you know, we'll talk about outliers in a second, but if there are outliers, there'll be little circles out beyond here, okay? Open circles. And we have not yet seen any outliers, but we may. So, but next I want to talk about a couple of really cool functions. One of them is FAVSTATS and the other is called GROUPSTATS. So let's jump back and I'll get rid of the ink. Okay. So FAVSTATS deals with just a single numeric variable. GROUPSTATS deals with a single numeric variable with a grouping variable. What I mean by a grouping variable? Well, we could look at the GPA for freshmen, sophomores, juniors, and seniors. Then we have 4 groups. FAVSTATS would just do the GPA distribution for the whole school. But GROUPSTATS can break it down based on a a grouping like freshmen, sophomore, juniors, seniors, right? Or biological sex, males versus females, or race or ethnicity, right? These different categories, GROUPSTATS can handle. And let's take a look at that. It's extremely helpful. Okay, so FAVSTATS, and notice we're saying table and data. Okay, and here we go. So this is the values data. All right, and we've got the mean of 4.25. If you remember from all the way at the beginning of the video, it tells us the standard deviation, okay, and the minimum, and it tells the maximum. So we have the 5-number summary in here too, okay. Tells us the IQR, tells us the number of numbers, okay. But that was just a 4-item data set, okay. So here's a total compensation for San Francisco government employees, okay. Wow, okay. So notice we have outliers, and we have what looks like hundreds of outliers, right? So every single one of these open dots represents an outlier, okay? So this is showing the breakdown. This finds the mean for all the different categories, and we're using dot group. Notice this, so we can group by the organization group. And then for each component, we're getting a mean, okay? And here, right, we're getting the total compensation mean. So we did this both with the NP mean. No, we did both of them. This one is just sorted. Okay, so we have the highest paid at the top. Okay, and here are the standard deviations. And don't worry about the what looks like a little bit of an error, but it's not. It's just that Python's a little bit whiny sometimes. It's complaining about something and we're going to ignore it as long as it doesn't throw a real error. Okay. And then we're going back and we're selecting the organization group, the columns organization group, and count. And we can see who's making the most money. How do we answer this? Well, we do sort descending equals true so that in the total compensation max, right, the group that's making the highest average, or excuse me, the highest maximum of everybody in the group, those are listed. And so, of course, the finance people, the people who decide who gets the what salary, right? They're the ones who are making the most, believe it or not. All right. And who is making the least money? So we're doing dot group, and notice here that we're using the min. Okay. And notice that, of course, culture and recreation are getting paid the least, and public works and transportation and commerce. Yeah. Okay. They're making less, but of course, there are other people that make a good bit more. And then what does the group stats do? Okay, so notice that the group stat tells me a table and then the grouping variable and then the numeric variable. And so let's get it going. So United, this is airlines, flights. by United Airlines. Okay. And sorry, first thing that we did was San Francisco. And notice what it does. It does a breakdown for every single group. Every single organization group has a FAVSTATS, right? So every row is what FAVSTATS would do if we just singled out that group. Okay, but what group stats will do is it'll take a category variable like organization group and it'll get all of the descriptive statistics for every single one of the groups. And so I can see it all at once. Now, there are a bunch of numbers in this table, so sometimes group stats is really, really helpful. And sometimes there's so much data in the display from group stats that it's a little overwhelming. Okay, this is what I said, the United flights, okay? And then we're doing, hey, what about the delays? What do the distribution of the delays look like? And notice that the median is 2. So in the middle of all of these flights, right, is about a 2-minute delay. And notice that a negative delay is these flights were 16 minutes early. Yes, and these were 2 minutes early. These were 18 minutes late. Notice this, 580 minutes. Goodness, that's almost 10 hours. Wouldn't 600 minutes be 10 hours? Okay, wow. But look at this. We can group them by, well, let's show it. So here we're doing group stats with destination is the grouping variable and delay is the numeric variable. So the group is destination. And we can see which one of these, like STL is St. Louis, IND is Indianapolis, BWI, that's Baltimore, Washington International, right? And we can see what the median times are, right? We've sorted based on N, the number of flights into that particular destination. And we can see these delays, but man, this is a huge table. Again, I think it's really cool to use group stats, right? But here we've got an option where instead of where we're calculating the average, right? And so yeah, really, really cool. Is there a lot of numbers? Yeah, there are. So again, group stats is really cool. If we have a huge number of groups, we get a huge table, which is somewhat overwhelming visually. So we have to be careful with that. Okay, and then outliers. So we have 2 ways in this course that we're going to identify outliers. One way is we check a number in the data set and see if it is 2 standard deviations away from the mean or more. Then I can call it an outlier. Or, and this is the way the box plot does, I have this IQR number, and to find if something is more than Q3 plus 1.5 IQRs, if it's higher than that, it's an outlier above. Or to check outliers below, we can do Q1 minus 1.5 times IQR. So that's how the box plot actually figures out the outliers. That's how it draws its fences, okay? So that's what's described here in method 1 and method 2. And let's show this. Okay, so what happened? Well, right here is Q3. And the way we determine outliers is we do Q3 plus 1.5 times IQR. So sorry, I do struggle a little bit when I'm trying to type with the mouse or write with the mouse, okay? So I take 1.5 times the IQR. Remember, the IQR is just the height of the rectangle, right? So I multiply that by 1.5 and I add it to Q3, and that's how I get what's called the upper fence, okay? And then anything that gets outside the fence, these are outliers. Everything above the fence is an outlier. So the upper fence is Q3 plus 1.5 IQRs. And again, the lower fence down here is Q1 minus 1.5 IQRs. That's how we determine outliers for the box plot. Okay. And they're going to do that in the, they're going to do FAVSTATS for the total compensation for the San Francisco employees. Using method 1, you can see, right, that we take Q1 minus 1.5 IQRs. Oh, I'm sorry. Here we're actually taking, method 1 is to go 2 standard deviations above or below the mean. Here we're going 3. So this is the mean minus 3 standard deviations, which is actually a negative number. As bad as the salaries are at the bottom end, they're probably not negative. And then the upper bound takes the average and adds 3 standard deviations to it. And that's almost $300,000. Method 2 is the one I was trying to describe. That's the 1.5 IQR. So this is Q1 minus 1.5 IQR. And it doesn't give a 78,000 negative number, but it gives a negative number that's close to 63,000. And the upper bound again is Q3 plus 1.5 IQRs. Boom. All right. So method 1 is less likely to identify a data point as an outlier than method 2 in general. And they have an example of this. And there you can see that method 2 has identified more outliers. I'm sorry. Yeah, you can see, right? The total number of outliers for method 1 was about 2,600, but there are over 9,000 in method 2. Why is this important? Not so, just to show you that they're slightly different calculations, right? We can see what's going on. Again, calculating them both ways. You see here, instead of 2,700 outliers with method 1, here with method 2, there are over 10,000. Okay. Method 1 turns out to be more popular with researchers, and this may have to do with the fact that the presence of outliers in a data set can sometimes invalidate statistical analyses, so researchers prefer to use a method that is less likely to detect outliers. Okay? But the box plot uses method 2, so we are going to talk about that one a good bit in this course. Okay? And so that's the key takeaways, right? That we've got these ways to calculate descriptive statistics. We have a way to detect outliers, specifically in the box plot. And then the box plot will show those outliers above and below the fences as open dots. And please remember to use NP median instead of NP percentile to find the median. Okay, have a great day, everybody.